Okay, welcome back. So today we will discuss the difference between pneumatics and hydraulics. So in the last lecture I have already discussed about what is fluid power and what are the application of the fluid power. So today we will just see that what is the difference between the pneumatic and hydraulics, and accordingly we will find out that what are the concept which is used in the hydraulic systems, and what is the basic concept. So if we talk about that hydraulics, what is hydraulics? So if we think that in our mind, the old definition is anything which is in affiliation with the water is called hydraulics. Means whether the water is flowing, water is stationary, we just try to understand this is the hydraulics. But as I told you that the new definition, new era definition, it is nothing but it is a transmission and control of forces and movement by means of fluids is called hydraulics. So transmission means in the case of transmission mechanism where you want to transfer the load or transfer the mechanism uh, or transfer the system, right? And sometimes you have to control the forces and movement. We use the hydraulic systems. So in the case of hydraulic system, we use the pressure of the fluid, right? And this pressure is capable to lift the high load, very high load, right? Now how it is possible, let us see, to try to understand, and we have to see the Pascal principle. It means the Pascal law. So Pascal law means it is basically the effect of forces on the stationary liquid is such that the force is spread equally throughout the liquid in all directions. So means you can say that if in a closed chamber, and if you apply the force or if the pressure is generated, you will find out this pressure will be constant and equally measured on the surface, right? So this is a constant pressure which is applied on the walls of the chamber, right? So therefore whatever force is applied here, you will find out this pressure will not be changing, it will be constant throughout the direction. So let us continue to understand this small difference, that suppose in the first case, if we try to understand the application of the force transmission, you will find out, in this case you will find out the area of this cross section is say A1, and if we apply the force F1 at this point, you will find out the pressure will generated here is P1, and on the other side if you see that the area of this side is larger than the area of this side, and the force is applied F2 in here, and the pressure is, suppose it is P2, right? So we know that the pressure equals to force upon projected area A1, and similarly here also P2 can be calculated. This is F2 divided by A2. But you can see that this two different sections are interconnected. So you will find out that this pressure at this section and this section will be equal. It means the P1 is equals to P2. So therefore, if we consider the equilibrium condition as understand the Pascal law, you will find out P1 equals to P2, or this is equals to F1 upon A1 equals to F2 upon A2. So therefore, you will find out F1 upon F2 equals to A1 upon A2. So therefore, you can find out that if F1 and A1, A2 are known, you can find out the value of F2, right? So since here the P1 is equals to P2. So with the help of this equation, you can find out that what load can be lifted off at this section. Okay, so here you can understand that the application of the force transmission, you can apply the force here very less, right? And you can here you can lift a very heavy weight, right? So for any given pressure, the greater area, the greater the force. It means here you will find out the area is greater, here the area is less, but the pressure is constant. So you can find out the advantage that if the area is greater, you can apply here the greater force, or you can lift the greater weight. Okay, so let us try to go for a simple calculation of the force transmission. that suppose the mass of the elephant is, say here is equals to 300 kg. Now A1 is equals to this is a 25 centimeter square. Now A2 is equals to say 75 centimeter square. Now what effort is applied at this section you can easily calculate, right? So it will be obviously F1 is always lesser than the F2. It means this is the advantage of the Pascal law, where you can use the force transmission and this maximum load can be transmitted with the help of the smaller load. Now this you can easily calculate because F1 upon F2 equals to A1 upon A2, right? So this F1 calculated. Similarly, if we talk here about the displacement transmission, you just try to understand here because this A1 is lesser than the A2, so therefore the volume 1 V1 is here is equals to the volume V2, because whatever stroke will be taken here in this piston, it because this pressure is constant, so how much you can say that displacement of the piston cover here, you will can get the displacement at this end S2. So S2 is less than S1, right? So therefore, because the volume at displaced at this section will be the same is equals to V2. So therefore V1 equals to V2. So V1 equals to A1 into S1, area into displacement. Similarly, V2 can be calculated. This is area multiplied by S2. So you know that since the under the equilibrium condition, the V1 equals to V2. So therefore, this equals to A1 S1 equals to A2 S2, or S1 upon S2 equals to A2 upon A1, right? So suppose if you want to calculate the displacement at this larger end, you can easily calculate by putting the value of S1, A1 and A2. So we can say that if we want to conclude the concept, for a given displaced volume of liquid, smaller the piston surface area, the greater the stroke. इसका मतलब ये है कि if you decrease the area of this section, you can get the maximum deflection. If deflection is our requirement by using the fluid power, then we can get the maximum deflection by applying here the small deflection at this larger area or larger end. Okay, you can also calculate with the help of this small example that if S2 is equal to say 5 centimeter, A1 is say here 25 centimeter, A2 is say 75 centimeter. Now what will be the S1 here? Okay, so you can calculate the required stroke of the piston at the smaller end, which is larger than the this S2, right? Now here we have to understand the pressure transmission application. You know that at this section A2 is smaller, at this section F1 is this A1 is greater than A2. Okay, so since P1 and P2 both are basically here the constant, or you can say that these are two you can say it is a constant at this area and it is constant at this area, but it is not equal. It means P1 is not equal, P2 will some another as compared to the P1. So we have to calculate here for the equilibrium condition. We can find out that F1 equals to F2, right? So F1 is equals to, in term of pressure into area, it means F1 equals to P1 multiplied by A1, and F2 can be calculated P2 multiplied by A2. Since these two pistons are interconnected with the help of a rod, you will find out the force which is applied at this end will be exerted by this end or experienced at this end. So therefore, you can say that the P1 upon P2 equals to A2 upon A1. So this is basically the concept of the pressure transmission. Okay, so here we can say that for a given force, the smaller the area, greater the pressure. Okay, it means this area is smaller, you will get here the maximum pressure, whereas the pressure is this section will be smaller. So P1 is smaller than P2. So if you required the pressure transmission, you always keep the smaller area where you can get the higher pressure of the fluid. Okay, this is a small mathematical again equation which you can easily solve, that if P1 equals to 100 bar, A1 is equals to 75 centimeter square, A2 equals to 25 centimeter square. Now calculate P2. Now what is the P2? Obviously P2 is greater than P1, right? Okay, now here we have to just try to understand that what is the difference between the hydraulic system and pneumatic system, and how we can differentiate these two systems. See, hydraulic system employs a pressurized liquid as a fluid, whereas in the case of pneumatic system we use gas or air, right? So this air is as a fluid which is used. As I told you that in the case of hydraulic system, a maximum pressure developed, a high pressure developed, up to say for example 700 bar, whereas in the case of pneumatic system which works under the low pressure, say it is say 5 to 10 bar. So you can see in comparison that the design part of pneumatic system and the hydraulic system are totally different. Okay, so generally the designed as a closed system, this is a closed system. Okay, it means there is no leakage. If there is any leakage, then what happening, the pressure will decrease or you will not get the efficiency of the system. So in this case usually it is designed as a open system. So you can say that the air is sucked from the atmosphere, and when the work is done the air will release to the atmosphere again. The system slows down when the leakage occurs. If there is any leakage in the system or the oil will leak, what happening, the system will not perform its duty, or you will find out the system will slow down, right? Whereas in the case of your pneumatic system, it will not affect the system much, right? So pneumatic is basically the air, and it is a continuous air which is compressed in the system. So this is basically used, this is the advantage of the pneumatic system also. So valve operations are difficult in the case of hydraulic system, where the valve operation are easy. We'll see in the next slide how the valves are operated. Now, as I told you, because the design of the hydraulic system is always complicated as compared to the pneumatic system, and if you see the weight of the hydraulic system, it is heavier, whereas the pneumatic system is lighter in weight. So in the case of hydraulic systems, we use the pumps to pressurize the liquid, whereas in the case of pneumatic system, we use the compressor to provide the compressed gases or air. The system is unsafe to fire hazardous because we are using the oil. Okay, so if it is a failure, or if there are any type of leakage in the pipes or any tank, you will find out it may catch the fire, right? The system is free from fire hazard because the air is leaking. You will not find out any um fire accident in the case of pneumatic system, or you will not listen any kind of fire hazardous in the case of pneumatic system. But in hydraulic system you will have some information that how the system get the fire. Automated lubrication is provided, yes, because the entire system is entire the system is having a oil. Okay, so there is no requirement of the lubrication because the plunger or all these things are automatically lubricated, or always all time it is lubricated when the oil is flowing inside the system. But in the case of pneumatic system, we use some special arrangement for the lubrication. If there are some rotary part, or you can say the moving or sliding part, we have to apply the external lubrication system. Okay, so let us try to understand here the basic component of the hydraulic system. As you know that we have to use, the first is the oil or sump, where we fill the oil, or it is called as oil tank. And this oil is first moved to the filter, where we have to remove any foreign particles which are inside the oil. Okay, so we use the filter because if there are any dust particle or any metal particles which are available in the oil, it may damage your system. Then we use a pump to pump the oil, and this pump is running with the help of motor. So we can increase here the pressure, right? So the pump is basically increasing the pressure of the oil, and this is first goes to the pressure regulator where we have to control the pressure, right? And then it will move to the direction control valve. Direction control valve basically used to control the forward direction of the fluid or in the reverse direction of the fluid, right? So this we can control with the help of the direction control. Then it will move to the inside the piston or this mechanism, or you can say it's a actuator, which is just like a piston and cylinder arrangement. So this actuator can move two-way, it means in the forward direction or in the reverse direction to up the weight or load to reverse the load. So basically idea is to control the fluid, right? So we can control the actuator movement. So this if we give here the pressure inside the fluid, and this will fluid pressure will apply from the top, right? So it will move down, and when the pressure here is developed, it will move the up. So therefore it will again move to the direction control valve, and direction control valve will decide that it should move in this direction or it should stop in this direction or in the reverse direction. So therefore this fluid will again move to the oil tank. It will not move to anywhere. So this is a closed system. This is a complete closed system, and these are the basic component of any hydraulic system. Any hydraulic system, right? Okay, similarly we can see this diagram, which is very important to understand that how a pneumatic system works and what are the basic components involved in the pneumatic system. So as I told you in the last discussion that the air is taken from the atmosphere and it is filtered and goes to the compressor, and the compressor will compress the air, and this compressor is running with the help of the power supply or with the help of motor. So with the help of motor is coupled with the help of this compressor, and this you can see while pumping the air in your bike or motorcycle or any vehicle, you will see that the compressor is run with the help of motor, and motor is continuously rotating the compressor, and compressor is having some pressure switch, or you can say that regulating switch, so that if there is a limit, or you can say that the pressure inside the compressor is very high, right? So what happening, we can regulate this pressure, and the remaining air will be moved out. It will not move inside the compressor or cylinder where we compress the air. Then this, because the pressure of this compressed air is very high, we have to use the air cooler, right, to cool the system, and this will move to the storage reservoir. Now basically this is the tank where we have to use the compressed air. We filled the compressor air, which is compressed by the compressor. So this storage reservoir is controlled with the help of a pressure switch, and because it's a closed loop system, where closed loop mechanism which is small used here, and then it basically opens when the pressure is reached. Pressure is reached means when the maximum pressure developed inside the reservoir, it is controlled with the help of a pressure switch, and it is motor will be automatically switched off. Then we can run our system, the similar type of system, it means the air actuator can be run with the help of this pressurized gas, and the direction control valve will control the direction, it means in the forward direction or in the return direction. So you can use here that at the one it is off, and the second means it is in the forward direction, and third is in the return direction, right? So this will move to the air actuator, and air actuator will work under the high pressure developed of the air, so that you can lift the weight or you can release the weight with the help of air actuator in two-way valve system. So that here we can use the direction control valve, and air will move to the atmosphere, right? It will not move to the reservoir anywhere, it will move to the atmosphere when the work is done in the air actuator. So this is the basically the pneumatic system and its component, basic components which are always used in any kind of pneumatic system. So it's a entirely open system. If you try to understand, you will find out the air is stored here and it is released to the atmosphere. Air is taken from the atmosphere and finally it will move to the atmosphere when the work is completed. Thank you very much.